In this video, you're going to learn about geometric sequences. Now, to remind you, a geometric sequence is a sequence where each number is attained by multiplying or dividing. So for example, we have the sequence 2, 6, 18, 54, etc. Notice that the pattern is each time I'm multiplying by 3. Right? 2 times 3 is 6. 6 times 3 is 18, etc. So if we're trying to find the 12th term, we could just multiply by 3 over and over and over again. And in this case, it wouldn't take too long to do that because there's only 12 terms. However, we want to learn a shortcut where we don't have to keep multiplying over and over again. So the shortcut, or the formula, to find a given term number is very similar to the formula for arithmetic sequences, where we begin with the first term and we see the pattern is we're multiplying by 3 over and over again, and the question is, how many times do I multiply by 3? So I begin with 2, right? I take 2 and multiply by 3 a certain number of times. So multiply by 3, and the question is how many times, right? Well, don't be deceived by the 12. We don't multiply 12 times. We're actually multiplying 11 times because we started with 2 and then we multiply by 3. So the first term did not require any multiplying, but the second term we multiplied by 3 one time. Third term multiplied 2 times. Fourth term 3 times. So the 12th term would be 11 times. So we multiply by 3 11 times. So we have 2 times 3 times 3, 11 times. And the way we write that with math notation is we can write that as 3 to the 11th power. So if we do 3 to the 11th power, we get 177,147. Then multiply by 2. My 11th term, or 12th term, would be 354,294. So that is the answer to this question. What is the 12th term? Now, to derive an equation from this, we can look at what we had right here. So right here, we had 2, which was our first term. That was T1. And then 3 was our common ratio, which is the number I'm multiplying over and over again, which, by the way, is a term to know. The number you're multiplying by is called your common ratio. So R is your common ratio. That's the number you're multiplying by. And then 11, we take the term number, so 12, and then subtract 1. So term number, which is n, and then subtract 1. And so all that is to find a given term number. So Tn equals T1 times r to the n minus 1 power. So we see it over here in red as well. That would be my equation. Now going back to the term common ratio for a second, if you're wondering why we use the word ratio to signify what number you're multiplying by, it is because we can take any number. So if we take the 6, for example, and then divide it by the number before it, which would be the 2, that would equal 3. If we do that with any two numbers, 18 over 6, for example, that would equal 3. 54 over 18, that would equal 3 as well. This ratio, this fraction, is the same no matter what. So when you determine the common ratio, you can find that by taking a number and dividing by the one before it. Now, what if we had this sequence and we wanted to know multiple different terms within the sequence? So maybe we wanted to find the 12th term, but also wanted to find the 20th term, and then the 25th term, and then maybe the 100th term. And we were using the same sequence over and over again. So we could shorten this a little bit by plugging in the things that will not change each time, and then just leaving n in there to plug in the term number as needed. So for example, given the same sequence, If we wanted to make it maybe a little simpler for multiple calculations, we take our equation and plug in everything except for n. So t1 is the first term, which is 2. Plug that in. The common ratio is what we're multiplying by, which was 3. So plug that in. So we have 2 times, that should be a 3. 2 times 3 to the n minus 1 power. So we have this. And we cannot combine the 2 and the 3 because they're not like terms, I guess, or another way of thinking of it is we would do the exponents first and then multiply. So this would be my equation in general. So what this does for me is if I wanted to find, let's say, the 30th term, it saves a little bit of time because I can plug the 30 in for n right here and get my answer. That'd be t30. So just plug in one number, the 30, instead of plugging in the 2 and the 3 also. And then if you wanted like the 100th term, all we do is we plug in the 100 in for n. We have that. So it makes it a little bit quicker if you're doing multiple calculations like that. So now, what if you were to find the 6th term given this sequence? So our equation is right here. All right, and then we just plug in numbers. So t1 is term 1, so that is 3. So t1 is 3. Your common ratio, your r value, is what you're multiplying by to get from term to term. Or if I don't see that, I can take a number, negative 12 for example, and divide by the one before it, which is 3. So when you do that, you get negative 4 as your common ratio. And then if we're finding the 6th term, n would equal 6. So we plug in those numbers, t1, which is 3, times negative 4, and then raise that to the n minus 1 power, so 6 minus 1 is 5. So make sure you follow order of operations, where you do the exponents first. So negative 4 to the 5th power, I can do on the calculator if you want. Make sure you put negative 4 in parentheses, and then raise to the 5th power. What that means, if you're doing it by hand, is you have negative 4 times negative 4, and then 5 times. So negative 4, 5 times in a row, multiply that together. And then once you have that, multiply by 3 in the front, and when you solve that correctly, you're going to get negative 3,072. All right, here is one more example. You are told to find the 12th term given this sequence. So our formula is right here, and we need to find t1 first. So t1 is term 1, or the first number, and that is 1600. R is your common ratio. I can find that by taking any number, so negative 800 for example, and then divide by the number before it, which is 1600. When you do that, the zeros would cancel. I have negative 8 over 16, which would reduce to be negative 1 over 2. And then n is the number of the term you're trying to find, which is going to be 12. So n is 12. All right, so we have that right here. Plug in the numbers. So t1 is 1600 times r is negative 1/2, and then n minus 1 would be 12 minus 1, which is 11 for the exponent. So this would be much easier to use a calculator with. You can type that in as negative, make sure you have parentheses, negative, and then do 1 divided by 2, or you get 0.5, same thing. So negative 0.5, raise that to the 11th power, and then once you have that on your calculator, multiply that by 1600. And if you do it correctly, you should get negative 0.78125. And that concludes our lesson for today. We will see you next time.